have over anything really. Anything related to pre-cal. All right, so today we're going to do somewhat of a review, and then on Tuesday we have our exam. These are the sections it'll cover, 6 sections, and I think after today, when we do a review, you'll have kind of a good idea of what is potentially going to be on the exam. All right, so no questions over homework? Anything you want me to talk about? All right, so here's how I'm going to do this. I'm going to go to the chapter reviews. I'm actually going to, well, I'll let you choose. Do you want me to start in chapter 7 and work my way to the end, or do you want me to start in chapter 8 and work my way backwards? Start at 7 and move forward? Okay. So I'm going to flip. If you have your book, great. If you don't worry about it. The chapter review for chapter 7 starts on page 600, but we are only doing 7, 6, 7, 7, and 7, 8. So I'm going to start by picking a problem here that I think looks pretty good. Something that would be fair game on the test. So, how about this one? Y equals cosecant of x plus pi over 4. Now the instructions I'm not going to write down because I don't feel like writing this all. Graph each function. Each graph should contain at least 2 periods. Use the graph to determine the domain and range. All right? So we want to graph cosecant of x plus pi over 4. So how do we do this? Set the things equal. So what am I really going to graph first? I'm going to graph the sine function first. So I'm actually going to pretend right now that someone gave me this function instead. Right? That's what I'm going to graph. And then from that, I'm going to draw these little u's, and that'll be my final picture. So I'm going to, you said set the inside, which we call the what? The argument. We're going to set the argument equal to 0 and pi. So 0 and 2 pi, sorry. X plus pi over 4 equals 0. The other equation, x plus pi over 4 equals 2 pi. And solve these. So x is equal to negative pi over 4. X is equal to 2 pi minus pi over 4. Hopefully by now you've done enough of these problems where you're starting to get a little faster with getting your common denominators and things like that. Do y'all feel like you are? So here I'd have to do 8 pi over 4 minus pi over 4, so I have a common denominator of 4. So this is just 7 pi over 4. So these are my 2 endpoints of my graph. Let's go ahead and start getting this together. It wants 2 periods, so I'm going to be prepared to do that. I'm going to start at negative pi over 4, which is going to be over here. And then 7 pi over 4, which I'm going to say is about right here. Now what?
Since it's sine, negative pi over 4 would be one of the x-intercepts.
Yeah, these are going to be x-intercepts, right?
And then after there will be the third.
So we're going to have to cut these up, right? I need to cut this up. I need to cut this interval in half, and then each of those intervals in half. So how do I get halfway between those two? Add them, divide by 2. Negative pi over 4 plus 7 pi over 4. Divide that by 2. That's 6 pi over 4 divided by 2, which is 3 pi over 2 divided by 2, reducing this fraction, and that's 3 pi over 4. Are you all comfortable with that yet? I mean, I know I've worked with a few of you, and I know, with more practice, you get a little faster and you get a little more comfortable with those. Everyone okay with that being 3 pi over 4? Okay. So I'm just going to put it midway, 3 pi over 4. And now I need to find the middle of these two, and then the middle of these two. So what's the middle of these two right here? I'm going to go negative pi over 4 plus 3 pi over 4 all over 2. So that's 2 pi over 4 over 2. You can also change this right now into 2 pi over 8. Like instead of reducing, you can just flip this, make it 2 pi over 8, and then reduce. And it becomes pi over 4. That's pi over 4. And that's here. It's halfway. Ooh, it's not a very good picture. Pi over 4. Now, we could get the halfway point here now, right? Which you could do mechanically by hand, but there's also another way you can kind of get this next one. If you just think about what it takes to get from one to the next, to the next, to the next, how much are we jumping up by? Look at the numerators. It goes from -1 to 1, 1 to 3. So what did I jump by there? 2. So the next one should be what? 5 pi over 4. You can do that without actually doing it here. And do you know why that's actually pretty useful? How many periods do I want? 2 periods, right? So that means I would need to draw another 1, 2, 3, 4, right? Another 4 marks out here. But if I follow this pattern, what would my next one be? 9 pi over 4. Next one. 11 pi over 4. Next one. 13 pi over 4. And 15 pi over 4. Isn't that kind of nice and convenient to do it that way? Now my final graph I'm going to do in blue. For now, I am going to do the intermediate graph of the sine in black. So I would have started here. I would have an x-intercept there. And where was the other one? At 7 pi over 4. And then I'd have an x-intercept right in the middle. Following that same pattern over here, where would my x-intercepts be if I continue that second period? 11 pi over 4 and 15 pi over 4. And now I need to draw a sine function, don't I? Yeah. Need to draw this sine function. Now, the way that I said to do it, to be safe, is to take a value and plug it into the function at this point. So what value would you like to plug in? Pi over 4, right? It's that first one between these two. So let's plug pi over 4 into this and see what we get. So what would sine of pi over 4 plus pi over 4, what would that be? That's sine of pi over 2. Sine of pi over 2 is the y-coordinate off the unit circle at the angle pi over 2, and that's 1. So that would just give me a 1, right? So out here at pi over 4, I go up 1. Here's 1. And then I know that at my 5 pi over 4, I'll be down at -1. Let me move this up just a little bit. 1. And then here, -1. And then what would it be at 9 pi over 4? 1. And then at 13 pi over 4? -1. And now I can draw my sine curve. Now I'm going to do it dashed because this is not my final picture. Yeah. Okay. Then from that, vertical asymptotes, because I'm trying to draw cosecant, right? So I'm going to draw my vertical asymptotes. Where do I draw those?
3 pi over 4, 7 pi over 4, 11 pi over 4, 15 pi over 4.
7 pi over 4, 11 pi over 4, 15 pi over 4. You good? You're squinting your eyes. You yes?
Yeah, the last three.
Oh, okay. Okay. All right. That's it. That's everything we need to draw it, right? So these are the things I'm going to be looking for on the exam. Okay. I will take off if you do not, like if you just get this point, this point, this point, and you don't get those intermediate points. I do take off for that because what I want is for you to kind of follow the same process. Yes?
So you mean like physically label the asymptotes on the paper, like write asymptotes?
You should label all these points. They should be labeled. Yes?
Do we need to do 2 periods?
Be prepared to do 2 periods. I'm not sure if I'll ask you to because of time, you know. But that's what the problem said. And the only reason I don't do 2 periods is just because of time. Yes?
Can you explain how the periods work again? Like why you had to go further?
Why I had to do another one? Because in the book it said draw 2 periods. That's the only reason I did that. Yeah. Everything I did in class was 1 period, right? But a lot of the homework problems, well, some of the homework problems wanted 2 periods. Do you understand how I got the 2 periods though?
Yeah,
Like how we're just jumping by the same amount? Yes.
Could you please explain the division of the pies again? I'm kind of a little bit fuzzy on the concept. So like you got 3 pi over 2 from 6 pi over 4 over 2?
Reduced over 2.
You just reduced it.
I reduced this fraction,
Okay,
that's
then
it.
you turn 2,
2 into
a
2 over
fraction,
1,
and then you flip
then
it
I
to
flipped it.
multiply.
Yep.
Okay. Just have to be sure.
Okay, so I'm going to draw my U's in here. They go like this. That'd be it. That would be 2 periods of cosecant.
And you're also going to want the cosine and dash lines. We take off points for that if we made it solid.
No, if it's okay. If this was solid, that'd be okay as long as you had the U's. It asks also for domain and range.
X is less than -1. That's y.
So what's the domain? What are the things that I can plug in?
Domain is all real numbers.
No. Hold up.
It's not even.
Yeah, hold on. Let's talk about domain. There are some problems with this, right? There are some issues.
Exclude -1.
We cannot have pi over 4, 5 pi over 4, right? I'm sorry, why did I say 5 pi over 4? I don't even know what I'm saying. Just tell me to shut up. Negative pi over 4 we cannot have because I have vertical asymptote. 3 pi over 4 I cannot have. 7 pi over 4 I cannot have, right? Now, if we go back and we think about what that looks like on the unit circle, where are those angles?
Odd multiples of pi over 4.
So pi over 4, where's 3 pi over 4?
3 pi over 4 is right there at the quadrant.
This one right here, right? Where's negative pi over 4?
Right there at the 45 and quadrant.
Down, negative though, right?
Quadrant 4.
Those two, can't have. How about 7 pi over 4? Where's 7 pi over 4?
Quadrant 3.
Nope. Do I have 7 pi over 4 here?
Yes, that's it.
7 pi over 4 is here, right? Where's 11 pi over 4?
There, on the other side.
This one?
It's
Right.
odd multiples of pi over
All right. It's these two, isn't it? I can't have these two. How do we say that? The domain x cannot equal, you can say negative pi over 4. That would get you, that would turn you to this angle, right? And then you need to be able to jump around back from here back to here, here back to here. And to do that, you're going to be rotating by pi. So plus n pi?
plus n pi.
Plus n pi. I gave you a quiz on that. By the way, I meant to hand all this back to you last time and I forgot.
What chapter was that?
7-6.
Yep, this is 7-6. So look, I'll pass this around. Remember you had that, I gave you a quiz where I drew circles and dots and asked you for general solutions? Okay, so at the time I gave that to you, it was kind of hit and miss as far as who got it and who didn't. But that is something that you are going to have to be able to do here, right? What I do not want, go ahead and you can just flip through it and grab your stuff. What I do not want is this. I do not want you to say x is not equal to negative pi over 4, 3 pi over 4, 7 pi over 4, and 11 pi over 4, and 15 pi over 4. I don't want you to say that. And the reason why is because even though I agree with you, you have not given me the proper domain of the entire function. I only asked you to draw 2 periods, but the function actually exists. It keeps going, doesn't it? So you've only told me what the domain is, what the restrictions are in the picture I told you to draw. This gives you the domain restrictions for the entire function. This lists them all out. Understand the difference between the two? Okay. All right, so that's domain. Range? Those are the y values, right? Everything below -1, everything above 1. So how do we say that? Negative infinity to -1, bracket, union, bracket, 1 to infinity. That's it right there. The only time that that would change a little bit is if the amplitude was different, like maybe the amplitude was 2, then this would be 2, -2, and then these would change, right? So just pay attention to that. Be careful. Question? Okay, let's look at another one. For those of you who may have come in a little late, I'm doing kind of a review. We're starting
The test review?
like the review for the test on Tuesday. Yes.
Oh, Tuesday.
Tuesday, yes. So how about this one? 4 sine of 2x plus 4, and then minus 2. Same thing here. I want us to graph this domain and range. Let's also throw 2 more things in here. I also would like to know, well, 3 things. Amplitude, period, and phase shift. Let's identify all of them. All right, so graph this, 2 periods, domain range, amplitude, phase shift, and period. So that means you're going to need to remember the formulas for amplitude, period, and phase shift. Do y'all want to do those now or do those later? Do them now? Okay, what's the amplitude? Amplitude's 4. Amplitude is just the absolute value of that number, right? So 4. Okay, period. How do you find the period? 2 pi, always 2 pi divided by the coefficient of x, so 2. So this is just pi, right? That's how long the period is. And then the phase shift, you have to be a little careful with the phase shift. Good. It's going to be, what's the formula for it? It's, what is it? Phi over omega. Now, where's phi? It's 4, but remember in the formula, the general formula for this is that we'd have sine, we'd have amplitude, sine omega x minus phi. Okay? So in the formula, there's a minus here, right? Here we have a plus, which means we need to look at this as being a minus -4, right? This is really minus -4. So that means that phi is actually what? -4. So -4 over omega, which is 2, right? So you get -2. That's our phase shift.
Why did you put a negative inside the parentheses?
Don't put x. Pardon?
Why did you put a negative inside the parentheses up there at top? Because you turned a +4 into a negative by putting it into the equation for a sin of wx of phi.
Yeah, I'm trying to make the inside of this look like this.
Yeah.
So
Wouldn't you set it make it a
2x
single
minus, make it a what?
Wouldn't you?
It's a plus, right? The only way I can make that a, like, turn that into a minus is if I look at it as a minus minus. So that makes our phi -4. What if this would have been -4? What would phi be? +4, right? So if it's plus, phi is the opposite. All right, let's do some graphing here. So what am I going to do to graph? Same story we just did a little while ago, right? We're going to set the argument 2x plus 4 equal to 0, 2x plus 4 equal to 2 pi. Ooh, this is going to be interesting. Setting the entire argument equal to 0 and 2 pi. Now the first one's not so bad. This one is x's, 2x's, -4, right? Which means that x is -2. The next one is a little bit worse because I subtract 4 on both sides. I get 2x equals 2 pi minus 4. And then I divide both sides by 2. I get x is what? Pi minus 2. All right. Say again, what? How come I subtracted the 2 from the 4? Where? Oh, I divide it. I divide. Divide everything by 2. We good? All right, now I need to put these on a number line. And I have a little bit of an issue here because I need to know where these are. Now I know where -2 is, right? But where is this relative to that? Is it to the left of it or is it the right of it?
Right.
It should be to the right because this is the same as saying take -2 and add pi, which should be that way, right? So here is -2. If I add pi to that, I've got to be over here somewhere. -2. How do I know that it's a positive number?
Because like 3.14 is about.
Yeah, this is about 3.14. So 3 minus 2 is going to be positive. So I know that's the general layout of what it looks like, right? Y'all good? Sure? Okay. Now, I'm going to need a second period. So if I go and add my second period, it should be over here, shouldn't it? Where will it be? 2 pi minus 2? Well, what's the period? Pi, right? So to get an entire period, another period, we need to add a pi to that, don't we? Add pi to this. What happens if I take that and add pi? 2 pi minus 2. Right? If I just add another pi to this, I'm going to get 2 pi's, and then I still have minus 2. So that would be my second one. Now, this is a little deceiving. This little line I have here, that's not really the midway point, right? That's not really halfway. Okay, so be careful with that. Don't let your y-axis confuse you. I need to cut this section into 2 pieces, and then each of those into 2 pieces. And then I need to do that again for the next period. So what's the midway point between here and here? So I'm doing -2 plus pi minus 2. I'm going to take that. I'm adding them together and then dividing by 2. And what do you get? It's going to be a weird number. Pi minus 4 over 2. That's what you get. That's halfway. I know it looks strange, but that's what it is. Pi minus 4 over 2. This problem is straight out of the book, okay? I'm not making this up, all right? Okay. What about the midway point between here and here? So I need to do -2 plus pi minus 4 over 2, but then all of that divided by 2. Same game, right? How do you add those two together? Common denominator. So I need to turn this negative 2 into what? Negative 4 over 2 plus pi minus 4 over 2. All of that over 2. What do you get there? Pi minus 8 on top. Pi minus 8 over 2 over 2. So pi minus 8 over 2 over 2. If I lost anyone? Anyone need a hand here? You good? Sure, sure. Say again, what? Common denominator, right? You okay with that part? Now I'm just doing negative 4 plus pi minus 4. So the minus 4 and minus 4 is minus 8. I still have the pi. So pi minus 8. But over the common denominator 2, but then all of that over 2. So what's this? Pi minus 8 over 4. Okay, that's what goes here. I'm going to get one more point, this one right here. I don't think I'm going to do the second period just for time constraints. Let's get that one. So I'm going to take what am I going to take? What am I doing here? Pi minus 4 over 2 plus pi minus 2 over 2. Ooh, this is interesting. I need a common denominator between these, don't I? So I need to look at this as being over 1. So I multiply top by 2, bottom by 2. So pi minus 4 over 2 plus 2 pi minus 4 over 2. All of this over 2. Just getting common denominator between those two.
3 pi minus 8.
Add them together, 3 pi minus 8. All over 2, but then all of that over 2. So it's over 4. Pi plus 2 pi, it's 3 pi. Negative 4 plus negative 4 is negative 8. Divide by 2, divide by 2. So it's going to be divided by 4. So that's this one. 3 pi minus 8 over 4. Okay. This kind of sucks, huh?
That's a shit problem.
Yeah. All right, now I'm going to do another period. We know that this was a sine function, right? You know what? Can we make it a cosine just because we haven't done a cosine? All right, do y'all want to make cosine? Because it'll be a little different if we do cosine. Yeah? Let's just change it to a cosine to make it a little more interesting. How is that going to change my approach? I mean, nothing changes like right now, right? It's this point right here. What do I do differently? My x-intercepts are not at the ends. And in the middle, it's actually at the quarter way marks, right? So it's here and here because it's a cosine function. And so all I need to really know is what's happening out here at negative 2. Am I up or down, right? Or I can also check, I could test this point, or that point. Any of those would work. What? Say again? You want to check at negative 2? Okay, so let's check at that's an easy one, right? Negative 2 to plug in. Okay, so if I test negative 2, I have 4 cosine of 2 times negative 2 plus 4 minus 2. Don't forget this minus 2 is going to come into play, isn't it? We're not there yet. I said we're going to use it, but don't forget about it. But we don't need it for this part. Okay. So here, what do we get? 4 cosine of 0. Cosine of 0 is the x-coordinate at the angle 0 on the unit circle. It's 1. So this is 4 times 1. This is 4. Right? Now I'll do the minus 2 after. Okay? So right now, if I were to graph this, at negative 2, I'm up at 4. Now I kind of erased my y-axis. Let's just imagine that the y-axis is somewhere in here. So I'm saying that that's 4, and negative 4 is down here. So that tells me my graph is going to start up here, go down, and then here at this point right here, midway point, it should be down at negative 4, right?
Yeah.
So it's going to go and then back up, and then back up like that. Right? Questions?
The y coordinates are 4 and negative 4?
Right now, this is 4 and this is negative 4. Those are the y. But we have not taken into account the minus 2 yet. That was just to get our picture drawn without any up and down shifting. So if I want to do this and get a final picture, I need to move every point down 2. So that means this point, I'll do it in blue. Instead of being at 4, it's at what? Straight down 2. Instead of this one being at 0, right? Y value 0, it's down here at negative 2. Instead of being at negative 4 here, I'm negative 6. And then here to here, and then this one to here. I know it starts to become a jumbled mess, but I was trying to get 2 periods in there. If I was doing 1 period, this would be a little bit more spread out and it would look a little better. Like that. That's it. All right, let's continue. We'll do one more graph. Let's do a cotangent. -5 cotangent of pi over 3 minus pi over, x over 3 minus pi over 4. So do we know what a cotangent looks like? Just to start, what does it look like? Cotangent looks like this, right? That's what cotangent looks like. Now, there is a little bit of an issue because we have a negative out here. And what is a negative going to do to this graph? It's going to flip it over. So it's going to look more like a tangent after we're done. But we're still going to follow a method. What is the process now? Set the argument equal to, for cotangent, what do we set it equal to? That's for tangent. For tangent, it's negative pi over 2 and pi over 2. For cotangent, it's 0 and pi. Those are things you're going to have to remember. Cotangent, 0 and pi. Tangent, negative pi over 2, pi over 2. All right, here, tangent, you set it equal negative pi over 2 and pi over 2. Cotangent, 0 and pi. Sine and cosine, 0 and 2 pi for both, right? Okay. Add pi over 3 to both sides. Multiply both sides by 3. Is that a question? What do you got? Yes, I did. I don't know why I did that. Thank you. Add pi over 4 to both sides. Good. That would have caused a problem, wouldn't it? Multiply both sides by 3, and you get x is 3 pi over 4. Okay, so that's one of the, not points on our graph, but that's an important part of our graph, right? This one, we add pi over 4 to both sides, and we should get 5 pi over 4. Now, I didn't show that work, but when you add pi over 4 to pi, you get a common denominator. Put them together, you should get 5 pi over 4. Multiply both sides by 3, 15 pi over 4. Now I'm going to put these on a number line. Three pi over 4 is smaller than 15 pi over 4, so it's going to be to the left of that. 3 pi over 4. Here's 15 pi over 4. And what should I draw now? Okay, so I know that right in between them, right in the middle, which I'd have to figure out what that point is, right? But what's happening right at the middle? What should I have there? Is part of my graph here is what I'm getting at. That's my x-intercept. I know that there's a point there, right? What about these points? What do these give us? The vertical asymptotes. So you want to draw your asymptotes off of this. Now, I know that it has to look like a cotangent, right? That's a cotangent. It's been flipped over because there's a negative, so really it looks like this. And what does the 5 out here do? Stretches it vertically, which I told you don't really have to worry about, all right? And if you want to, you can try and draw this stretched out. It would probably look like, it would look more like that as opposed to like this.
What is it when it's compressed? What's the opposite of that when it's compressed? It's closer to the x-axis?
Yeah, it would have looked like.
Yeah, but what's the function in the problem?
Oh, this would be a fraction, like not a fraction, but it smaller than 1.
Okay.
Between 0 and 1. Like if that was like 1/2, it would. Now this would almost be full credit. I'm forgetting something. That middle point, I just need to label this. So I need to take 3 pi over 4 plus 15 pi over 4, and then divide that by 2. 18 pi over 4. So 18 pi over 8 is what it turns out to be, which is 9 pi over 4. Okay, that's it. We're done. Yep. All right, moving on.
I'm sorry. Can you
Moving.
do the wave?
Do the wave?
The domain.
Oh, sorry. I thought you said, can you do the wave? I was like, I think I still can.
Part of the Spurs family.
We can all do the wave. Yeah, let's go. Let's start over here. The domain. Okay, yeah, so, this domain's going to, if you want domain off of this, you're going to have to actually figure out where these are happening. Okay, so maybe you can figure out what that distance is. I mean, because on a unit circle, do you know where those are? You know where those are?
Well, one is it
3 pi over 4.
quadrant 2 at 45.
That's this, right? So that's 3. 4 pi over 4, 5 pi over 4, 6 pi over 4, 7 pi over 4, 8, 9, 10, 11, 12, 13, 14, 15. So it looks like these two, right? Looks like those two.
3 pi over
What is this distance between these two?
pi.
Pi. How are you getting that?
Well, actually, it's not pi. It's 2 pi. 3 pi.
What's the distance between these two?
And then around one, that's another one. So
How do I find the distance between 2 points? Subtract them, right? So in other words, take that and subtract that. What's 15 pi minus over 4 minus 13 pi over 4? 15 pi over 4 minus 3 pi over 4 is 12 pi over 4, right? Yeah. So what is this? 3 pi? Yes? That's the distance. So we know that these 2 points are not in our domain, right? So here they are. And the way you can look at this is that if you start here, right, to get to the next bad place, you have to go 3 pi. So 1, 2, 3. So that's this one. Now to get to the next bad place, go 3 pi again. 1, 2, 3. Now you're back here, right? Next bad place, 1, 2, 3. Yes? Okay, so this one's tricky. I don't know if I would ask you this one. X cannot be, so start at one of these, right? Start at one of these.
3 pi over 4.
Now be really careful here. 3 pi over 4 plus 3 pi n. The important thing here is that even though the picture shows that you should just jump by pi, you actually do not get 7 pi over 4 here. 7 pi over 4 would be right there, right? But that actually is right in here. So they're 3 pi apart from each other is where you have the problems, which is why I'm jumping by 3 pi each time. That's a little tricky.
Does that work like every time? Like subtract the 2?
If you want to know the distance, oh yeah, absolutely.
Pretty handy.
Yeah. I mean, you already know that, though. It's just I'm saying it a different way. I guess right? What's the distance between those? You just subtract, right? It's this pi thing, right? This is almost like a new language. When you're learning it and that pi is sitting there, I think you sit there and just forget that these are just numbers, right? So all the stuff you did arithmetic with numbers is just now you got that little pi symbol, which for some reason makes our brains freak out a little bit. All right, let's proceed. There's more in this chapter we need to talk about. No, I think that's it. The rest of it is still graphing stuff. We'll come back to graphing if you want, if we have time. Let's get in chapter 8 stuff. All right, for chapter 8. Chapter 8 started out with the inverse trig functions. So how about, what's arcsine of 1? What's arctangent of 1? What's arcsine of root 3 over 2? What's arccosine of negative root 3 over 2? What's secant inverse of root 2? All right, so these we should be able to go through pretty quickly. All right, what is arcsine of 1? What is arcsine of 1? So that's telling me to look at the unit circle. Where's the y-coordinate 1, right? Y-coordinate because it's sine. So I'm looking at the unit circle. I'm saying where's the y-coordinate 1, which is here. And where am I not allowed to look?
In the quadrants
2 and 3 are off limits, right? These two are off limits because arcsine is not defined there. But that's okay because the angle is actually just pi over 2, right? Pi over 2 straight up. So pi over 2. All right. Arctangent of 1. This is saying on the unit circle, where's the y-coordinate divided by the x-coordinate equal to 1? Pi over 4. So that's going to happen right here because the y-coordinate is root 2 over 2. The x-coordinate is root 2 over 2. Where am I not allowed to look for arctangent? 2 and 4. Same thing. I'm not allowed to look over there. Okay. What is this one saying? Oh, I should put the answer. Pi over 4. This one is saying,
Pi over 3.
Where is y?
where's the y value on the unit circle equal to root 3 over 2? So pi over 3, right? That's because the y-coordinate there is root 3 over 2. Pi over 3, and I'm not allowed to look over here, right? Because there is actually another point on the unit circle where the y-coordinate is root 3 over 2. It's over here, but I'm not allowed to look there. So pi over 3. Okay, what about this one? This one is saying to us, where is the what equal to what? At what angle is the what equal to what?
Negative pi over 6.
At what angle is the x-coordinate equal to negative root 3 over 2? And that's going to be right there. Where am I not allowed to look? I'm not allowed to look on the bottom because it's arc cosine, right? Arc cosine only between 0 and pi. That's the only place you can look. So that angle you said was what? 5 pi over 6. Do y'all feel like you've come a long way in terms of like recognizing angles? I hope you feel like you have. Like knowing where they are? Okay.
What are all the signs that only work in quadrants 1 and 2? Arc cosine, what else? Or the C is C.
Arctangent?
Arctangent.
But there's a little bit of a difference. In the arc sine, you can include the two endpoints. Pi over 2 and negative pi over 2 are included. In arctangent, the endpoints are not included.
So you can't, okay.
You can't have pi over 2 or negative pi over 2. But that's because we had vertical asymptotes there. But so arc sine and arctangent have this basically the same
You guys
restrictions.
remember tangent has the asymptotes.
That's right. And then cosine, 0 to pi.
Cosecant and secant are the same?
Tangent? Little bit different. Little bit different. Let's do this one, okay? What is this one saying?
Where it's secant is it's root of 2.
Yes?
Where is secant root of 2? So
Uh,
arc of secant is cosine.
Kind of. This is supposed to give you an angle, right?
Mm-hmm.
So you should be thinking, at what angle on the unit circle is what? Is it the x-coordinate, y-coordinate, or neither? What is secant? Secant's the reciprocal of cosine, right? So this is actually saying at what angle on the unit circle is the x-coordinate flipped over root 2? Right? If you take the x-coordinate and flip it over, you get root 2. And I'm not allowed to look, this is what you're asking, I'm not allowed to look where? Well, secant is the reciprocal of cosine, so I will have the same restrictions I had on cosine.
Yeah, quadrants 3 and 4.
So I'm not allowed to look here. So can you think of anywhere where the x-coordinate flipped over is root 2? And it's got to be a common angle.
Pi over 4.
Probably here, right? Let's try it. The x-coordinate there is root 2 over 2. If I flip that over, right? If I flip that over, what do I get? What's 2 over root 2? Well, it's 2 over root 2, right? But you rationalize this one, and you get on top 2 root 2, and what do you get on the bottom? 2, and they cancel, and you get root 2. So the answer would be pi over 4. Any questions there? All right, let's step into a different territory here. Those are basically inverse trig functions at common angles, like at common values, that we should just be able to think through them and figure out where the angle is. Now things kind of switched up. We moved when we were moving through this chapter, and we had things like this. What's sine inverse of sine of 7 pi over 8? And what is the most common incorrect answer I'm going to be on this?
7 pi over 8.
7 pi over 8 is going to be the answer that someone's going to put, because they're going to say these two cancel each other out. And it does work that way sometimes. It only works that way when? This right here would have to be between negative pi over 2 and pi over 2. Then it just spits out the answer. But not here, because that's not between negative pi over 2 and pi over 2. So what did I say we should do here?
First find the value of
Oh, wait, hold on. I didn't mean to put 7 pi over 8.
Because you're actually there's a limit of 5.
I meant to put 7 pi over 6. I meant to give you an angle you can actually find. Sorry. Okay, that's what I meant. I apologize. So do we know where that is? Okay, pi over 6 is here, right? 7 pi over 6 would be there, right? That's 7 pi over 6? And I want sine of that, which is equivalent to asking, what's the y-coordinate? So what is the y-coordinate there? Negative 1/2. So this is now saying, what is arc sine of negative 1/2? And now that problem is just like the problems we just did. It's saying at what angle is your y-coordinate on the unit circle negative 1/2? However, you're not allowed to look in quadrants 2 and 4. You can only look in quadrants, 2 and 3. So looking for a y-coordinate to be negative 1/2, that would be over here, wouldn't it? Because I'm not allowed to look here. And that angle, careful, that angle, negative pi over 6, awesome. It's not, what, 11 pi over 6? It's not that. Because you have to use, your angle has to be negative. It can't come all the way around. Good. Yes? Just looking, I just found where 7 pi over 6 is as an angle, and that's right here. And we know that on a unit circle, the y-coordinate of this point is negative 1/2. The x-coordinate is negative root 3 over 2. So when you say, what's sine of 7 pi over 6? The answer is negative 1/2. Yes? Then you have to undo it. You have to say, okay, forget all this, forget all that happened, and just ask yourself this question. When you ask yourself that question, you're not allowed to look here. So you go say, where is the y-coordinate negative 1/2? And this time it's right here. You see this has the same y-coordinate as that one? They're directly across from each other? Does that answer your question? Okay. All right. Yes? Oh, someone? Yeah.
I think if you was a unit circle, are we allowed to use like a
Are you going to be so kind?
yeah.
generous.
You're a good man. Good man. Such heart.
How about this? This is exam 2, right?
Yeah.
We're almost 8 weeks into the semester. I'll do it this way. If you don't use the unit circle or any formulas, I will give you a 5-point automatic bonus on the test. If you use the formulas, if you want a unit circle, I will provide you one for a 5-point deduction on the test.
What? Deduction or like no points?
Shouldn't it be a 0 point?
Like, yeah, 0 points. Like if you use it, you get nothing, but if you do not, you get 5 points extra.
That's the deal.
That's the drawback is we talked about time constraints. People are going to have to take the time to create.
Well,
It's-
to me at this point,
I'm not
an A student shouldn't need the unit circle. Okay? So by me allowing you to use it, I'm just giving you the logic behind this. For me, if I'm going to allow you to use the unit circle, then it's going to be very difficult for you to achieve an A. And I think that's fair because an A student doesn't need a unit circle.
You mentioned formulas though as well, so you're telling me there's a lot of formulas on it also? I'm just trying to,
Well, so far, have I needed any formulas that, I mean,
Well, we need the.
what have we needed?
It'd be nice to have all the ranges and everything on.
Yeah.
I mean, just,
Yeah.
just have it.
Look, trust me, I was a student who was very bad at memorizing. Okay, I'm not a person who memorizes things. I have to understand them, and then they start to go in after a while. You asked about the unit circle, right? Okay, so for the unit circle, the deal is the deal. Okay, as far as other formulas, let me see. Is there a formula sheet in the book? Let me look at the back here real quick. I'm willing to provide you with the formulas off the back cover of the book, which I'll let you come take a picture of it at the end of class if you don't have a book, so you can know what. I will provide you with that for free. Okay? It has the Pythagorean identities on it, I believe. Does it?
That's the only thing it doesn't have.
The Pythagorean. Oh, no, it does. It has them. Left column.
Oh, okay.
They're there.
Double angle formulas.
So it has a good mixture of formulas in there that'll be helpful. But as far as the unit circle, yeah? Yeah. All right, let's proceed. We only have about 40 minutes left. How about something like this? Cosine inverse of tangent of 3 pi over 4. Different functions, right? Tangent and cosine inverse. So the approach to this is different than what we were just doing. What is tangent of 3 pi over 4 going to give you? An angle or a number? A number, right? It's basically the y-coordinate divided by the x-coordinate on the unit circle at the angle 3 pi over 4. So if I go, let's just go to 3 pi over 4 real quick. And the coordinates here are negative root 2 over 2 and positive root 2 over 2. So if tangent is the y divided by the x, so the ratio should be -1. -1, right? Okay. So this is really just saying what's cosine inverse of -1, right? And now that's saying to me at what angle on the unit circle is my x-coordinate -1? I can only look between 0 and pi. That's here. That's where my x-coordinate's -1. That angle is pi. Okay?
Do we have
Pardon?
to look at 2 restrictions or just 1?
Only one. The only thing that I'm restricted by is the arc cosine. Whatever its restrictions are the only ones I have to pay attention to. You do not have to look at, were you thinking like for the tangent also you have to? No, because there's no arc tangent in the problem. Good question. All right, let's leave that one up there. Let's compare that to something like, tangent